NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will connect the coefficients a, b, and c of a quadratic equation to the roots x sub 1 and x sub 2. We begin with the standard quadratic equation. When the roots are real, we will denote them by x sub 1 and x sub 2. Our goal is to derive three key relations: the sum of the roots, the product of the roots, and the absolute difference of the roots, all expressed in terms of a, b, c, and the discriminant. First, recall the discriminant delta equals b squared minus 4ac. The quadratic formula gives the roots at x equals negative b plus or minus the square root of delta, all over 2a. From that, we can explicitly name the two roots. We start with the sum of the roots. Add x sub 1 and x sub 2 directly from the quadratic formula. Combine like terms in the numerator and simplify. Next, the product of the roots. Multiply x sub 1 and x sub 2. Use x sub 1 and x sub 2. Use the difference of squares in the numerator, and then replace delta by b squared minus 4ac. Simplify to get the final expression. Finally, the absolute difference of the roots. Subtract x sub 2 from x sub 1 using the quadratic formula forms. Simplify the numerator and reduce the fraction. The result involves the absolute value of it in the denominator. To summarize, for the quadratic x squared plus bx plus c equals 0 with discriminant delta, we have three elegant identities. Sum equals negative b over a, product equals c over a, and absolute difference equals square root of delta over absolute value of a. These identities are extremely useful for checking solutions, building quadratics from given roots, and estimating how far apart the roots are. Practice deriving them from the quadratic formula until the patterns become second nature. In this lesson, we will use the relationships between coefficients and roots of a quadratic to compute sums, products, and the actual roots for example, equations. We'll build strong intuition as we go. For any quadratic ax squared plus bx plus c equals 0, the sum of the roots equals negative b over a, and the product of the roots equals c over a. We'll keep this at the top as our compass. Example 1. 3x squared minus 5x plus 2 equals 0. Using the rule, the sum of the roots is 5 over 3. The product of the roots is 2 over 3. Factoring shows the roots are 2/3 and 1. Example 2. 4x squared minus 3x minus 7 equals 0. The sum of the roots is 3 over 4. The product of the roots is negative 7 over 4. The discriminant is 121, so the roots are 7/4 and negative 1. Example 3. X squared minus 2x plus 1 equals 0. The sum of the roots is 2. The product of the roots is 1. This factors as x minus 1 squared, so the root 1 repeats twice. Example 4. 5x squared plus 6x minus 8 equals 0. The sum of the roots is negative 6/5. The product of the roots is negative 8/5. The discriminant is 196, so the roots are negative 2 and 4/5. Great. Let's summarize everything in a single table: coefficients, sum, product, and the roots. Key idea: the sum and product of the roots are controlled directly by the coefficients. Once you know a, b, and c, you instantly know x1 plus x2 and x1 times x2. From there, factoring or the quadratic formula reveals the roots. Example: we are given a parabola that crosses the x-axis at x equals 2 and x equals 6, and it passes through 0, 3. Our goal is to find the quadratic rule f of x. Let's sketch the essential features. We draw coordinate axes. Mark the two intercepts at 2, 0 and 6, 0. Also mark the y-intercept at 0, 3. Step 1. Write the general quadratic form. Y equals ax squared plus bx plus c. Step 2. Use the y-intercept. Because f of 0 equals 3, we immediately get c equals 3. Step 3. Use the roots 2 and 6 with the relationships between coefficients and roots, also called Vieta. C over equals x1 times x2. So 3 over equals 12, hence it equals 1/4. And negative b over equals the sum x1 plus x2. With it equal 1/4, we get negative 4b equals 8. b equals 8. So b equals negative 2. Step 4. Substitute a, b, and c. F of x equals 1/4 x squared minus 2x plus 3. Let's verify visually. We draw the parabola using this rule. Check f of 2 equals 0. Check f of 6 equals 0. The vertex occurs at x equal negative b over 2a, which is 4, with a minimum value of negative 1. Everything matches the sketch. Final answer. F of x equals 1/4 x squared minus 2x plus 3. In this example, we will solve for the parameter k in the quadratic equation, given that one root is the square of the other. Step 1. Let the roots be x sub 1 and x sub 2 with the given condition that x sub 1 equals x sub 2 squared. Step 2. Multiply both sides by x sub 2. Then we have x sub 1 times x sub 2 equals x sub 2 squared times x sub 2, which simplifies to x sub 2 cubed. Step 3. Use Vieta's formulas. The product of the roots equals c over a, which is 8. Since x sub 1 times x sub 2 equals x sub 2 cubed, we get 8 equals x sub 2 cubed. 8 is 2 to the third power. Therefore, x sub 2 equals 2. Now substitute x sub 2 equals 2 into the original quadratic to find k. We write open parenthesis 2 close parenthesis squared plus k times 2 plus 8 equals 0. Then simplify line by line until k equals negative 6. Therefore, the required value of k is negative 6. In this example, we will extract the parameter k from a quadratic using a relation between its roots. First, show the word example. Then state the quadratic and the root relation we are given. Step 1. Use Vieta's formulas for a monic quadratic. The sum of the roots is minus b over a, which here equals 5. The product of the roots equals the constant term, which is k minus 1. We will mainly need the sum. Step 2. Combine the given relation with the sum. Start from x1 plus 3x2 equals 7. Group as left parenthesis x1 plus x2, right parenthesis plus 2x2 equals 7. Replace the sum by 5, giving 5 plus 2x2 equals 7. Solve for x2 to get x2 equals 1. Step 3. If x2 equals 1 is a root, then substituting x equals 1 into the quadratic must give 0. Substitute to get 1 squared minus 5 times 1 plus k minus 1 equals 0. That simplifies to k minus 5 equals 0. Therefore, k equals 5. Quick recap. Vieta gave the sum x1 plus x2 equals 5. Combining with x1 plus 3x2 equals 7 produced x2 equals 1. Substituting that root into the polynomial forced k to equal 5. Example. We will solve for m from a quadratic where the difference of the roots is given. The equation is open parenthesis 1 plus m close parenthesis x squared plus 3x plus 1 minus m equals 0. We are told that x sub 1 minus x sub 2 equals 2. We will now follow the exact algorithm shown. Convert the difference of roots into the discriminate relation, substitute a, b, c, and simplify step by step until we isolate m. First, identify the coefficients. Here a equals 1 plus m, b equals 3, and c equals 1 minus m. Step 1. The difference of roots is 2. Step 2. Use the identity. Absolute value of x sub 1 minus x sub 2 equals square root of delta divided by a. So we write square root of delta over equals 2. Step 3. Multiply both sides by a to isolate the square root of delta. Step 4. Square both sides to remove the square root. Step 5. Replace delta by b squared minus 4ac, the discriminate formula, and set it equal to 4 squared. Step 6. Substitute a equals 1 plus m, b equals 3, c equals 1 minus m. Step 7. Multiply the binomials 1 plus m and 1 minus m to get 1 minus m squared. Step 8. Move every term to the left side to set the equation equal to m to get 1 minus m squared. Step 8. Move every term to the left side to set the equation equal to 0. Step 9. Expand the square 1 plus m quantity squared as 1 plus 2m plus m squared, and distribute. Step 10. Distribute the 4. Step 11. Combine like terms. The 4m squared and minus 4m squared cancel. For plus 4, minus 9 becomes negative 1. So we have negative 1 plus 8m equals 0. Step 12. Move negative 1 to the other side. Step 13. Finally divide both sides by 8. Therefore, m equals 1/8. Side. Step 13. Finally divide both sides by 8. Therefore, m equals 1/8. In this video, we will solve a quadratic equation using the exact algebraic steps shown in the provided solution image. We'll label it as example. Here is the given equation. Step 1. Write the equation exactly as given. Step 2. Add and subtract cleverly to prepare for grouping. We insert plus 4x and plus 3x. The value of the expression does not change. Step 3. Group the first two terms together and the last three with a common factor -3. Step 4. Factor out common factors in each group. From the first group, factor 4x, and leave the second group as is. Step 5. Recognize a sum of cubes. X cubed plus 1 factors as x plus 1 times x squared minus x plus 1. Step 6. Now the binomial x squared minus x plus 1 is common. Factor it out. Step 7. Expand the bracket to obtain a simple quadratic factor. Step 8. Analyze each factor exactly as in the solution text. The quadratic x squared minus x plus 1 has discriminate less than 0, so no real roots. For the second quadratic, we highlight that the sum of its roots equals negative b over a, which is negative 1. To complete the picture, we can also compute the individual real roots of the quadratic 4x squared plus 4x minus 3 equals 0. Using the quadratic formula gives x equals 1/2 and x equals negative 3/2. Their sum is indeed negative 1. In this example, we use algebra and Vieta's formulas to evaluate a neat expression. Consider the quadratic function f of x equals ax squared plus bx plus c, where a, b, and c are all non-zero. The roots are m and n. The 5 numbers a, m, b, n, c lie on one arithmetic sequence. We will find the value of f of negative 1 plus f of 1 minus 2f of 0. Step 1. Evaluate each piece directly from the definition of f. F of negative 1 equals a minus b plus c. F of 1 equals a plus b plus c. F of 0 equals c. Adding them as f of negative 1 plus f of 1 minus 2f of 0. The b's cancel and the c's cancel, leaving exactly 2a. Step 2. Use the arithmetic progression information. Here is a number line showing 5 equally spaced points, a, m, b, n, and c. In any arithmetic sequence, middle terms are averages of neighbors. So b is exactly the average of m and n. That means m plus n equals 2b. Step 3. Apply Vieta's formula for a quadratic with roots m and n. The sum of the roots equals negative b over a. Step 4. Combine the two facts about the sum. Set 2b equal to negative b over a and solve for a. Since b is non-zero, divide both sides by b to get 2 equals negative 1 over a. Therefore, a equals negative 1/2. Finally, return to our simplified expression, which was 2a. Substituting a equals negative 1/2 gives 2 times negative 1/2 equals negative 1. So the value of f of negative 1 plus f of 1 minus 2f of 0 is negative 1. Recap. We evaluated the expression directly to get 2a, used the arithmetic progression to show m plus n equals 2b, applied Vieta to write m plus n equals negative b over a, solved for a, and finished with negative 1. In this lesson, we will follow a structured algorithm to solve a rational equation, and then compute the ratio s over p of the roots. The problem on screen is the one we will solve step by step without changing the order of steps. Step 1 in the algorithm. Verify that denominators never become 0. For the first denominator, compute the discriminant b squared minus 4ac. Do the same for the second denominator. Both discriminants are negative, so denominators are never 0 for real x. Next step in the shown algorithm. Subtract 1 from each fraction and add minus 1 and minus 1 to the right side. This rewrites the equation, so the right side becomes 0. Now apply the identity a over b minus 1 equals a minus b over b. Expand each numerator carefully. Notice both simplify to the same trinomial in the numerator. Factor the common numerator. The expression becomes the common factor times a sum of positive fractions. Since denominators are positive for all real x, the bracket cannot be 0. Therefore, the numerator must be 0. Follow the algorithm, work with the quadratic, and use the sum and product of roots. Multiply by -1 to get the standard leading positive coefficient. 4ax squared plus bx plus c equals 0, s equals -b over a, and p equals c over a. Substitute a equals 1, b equals 6, and c equals -5. Finally, compute the ratio s over p and express s in terms of p. S over p equals 6/5, which is 1.2. Therefore, s equals 1.2 times p. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.